From the dawn of humanity, we've looked to the sky in awe. The sun, that blazing orb of light and heat, has been a constant companion in our journey through the cosmos. But how much do we really know about this celestial giant that governs our little corner of the universe? In this odyssey, we'll journey into the heart of our solar system to unveil 5 mind-blowing facts about the sun. Prepare to be amazed by the sheer scale, power, and complexity of this star we call our own. Fasten your seatbelts as we're about to embark on an unforgettable cosmic adventure. Let's start with perspective. Our planet Earth, this magnificent blue sphere we call home, seems vast and mighty. But when compared to the sun, it's a mere speck of dust. Imagine holding a basketball, that's the sun. Now picture a tiny, minuscule poppy seed placed beside it. That, my friends, is Earth. The sun dwarfs our planet in every dimension. You could fit over 1.3 million Earths inside the sun's colossal sphere. To put that into perspective, if the sun were an empty ball, you would need a chain of 109 Earths just to stretch across its diameter. But size is just the beginning. The sun's gravity is what holds our entire solar system together. All the planets, moons, asteroids, and comets dance to its tune. It's a cosmic ballet orchestrated by the immense gravitational pull of this star we call our own. Think about that for a moment. The same force that keeps you anchored to the Earth is the very same force that binds our solar system to the sun across vast distances. It's a humbling reminder of our place in the grand cosmic tapestry. So the next time you glance up at the sun, remember the sheer scale of what you're witnessing. It's a giant among giants, a cosmic ruler that dictates the dance of our planetary system. Now let's delve deeper, past the sun's surface, into its very core, a realm of unimaginable power and fury. Here, temperatures soar to millions of degrees, and the pressure is so intense that atoms themselves are ripped apart. This is the realm of nuclear fusion, the sun's energy engine. In this inferno, hydrogen atoms, the simplest and most abundant element in the universe, are forced to fuse together, creating helium and releasing an unfathomable amount of energy in the process. Imagine for a moment the power of 1 billion atomic bombs detonating every single second. That, my friends, is the energy output of our sun, a continuous, self-sustaining nuclear reaction that has fueled our star for billions of years. This energy, radiating outwards in the form of light and heat, is the lifeblood of our solar system. It's the reason we exist, the reason life flourishes on our planet. Every leaf that unfurls, every wave that crashes, every breath you take, all powered by the distant furnace of our sun. It's a humbling thought, isn't it? That something so far away, so seemingly removed from our daily lives, is intimately connected to our very existence. Let's peel back the layers of our sun, like an onion, to reveal the secrets hidden within. We begin with the photosphere, the visible surface of the sun. This is the layer we see from Earth, a blindingly bright sphere that defines the sun's disk in our sky. Moving outward, we encounter the chromosphere, a dynamic region of fiery jets and prominences. Imagine colossal loops of plasma guided by the sun's magnetic field, reaching thousands of kilometers high. This is a realm of constant change and activity. Beyond the chromosphere lies the corona, the outermost layer of the sun's atmosphere. This ethereal halo, visible during a total solar eclipse, extends millions of kilometers into space. It's here that the solar wind, a stream of charged particles, originates, constantly flowing outward from the sun. Back towards the interior, beneath the photosphere, lies the convective zone. Here, vast currents of plasma carry heat from the sun's core outward, much like a boiling pot of water. These currents create the mottled appearance of the photosphere, known as granulation. And finally, we reach the core, the very heart of our star. It's a place of unimaginable density and temperature, where nuclear fusion reigns supreme, generating the energy that sustains our entire solar system. Imagine a constant stream of charged particles, a cosmic wind flowing outward from the sun at speeds of millions of kilometers per hour. This is the solar wind, a relentless force that shapes the environment of our entire solar system. This wind, composed primarily of protons and electrons, carries the sun's magnetic field far out into space, creating a vast bubble known as the heliosphere. Think of it as the sun's magnetic domain, a protective cocoon that shields us from the harshest radiation from interstellar space. But the solar wind isn't always benign. When particularly intense bursts of solar wind, known as coronal mass ejections, collide with Earth's magnetic field, they can trigger geomagnetic storms. These storms can disrupt satellites, communication systems, and even power grids on the ground. However, these storms also create one of nature's most breathtaking displays, auroras. As charged particles from the solar wind interact with Earth's atmosphere, they paint the sky with vibrant hues of green, red, and blue, a celestial ballet of light. So, the next time you witness the ethereal glow of an aurora, remember that you're seeing the visible effects of the sun's breath, a reminder of our star's constant influence, even from millions of kilometers away. Like all stars, our sun has a life cycle, a story written in the language of nuclear fusion, gravity, and time. It's a story that began billions of years ago and will continue to unfold for billions more. Our sun is currently in its main sequence phase, a long, stable period of hydrogen fusion. But this stability won't last forever. In about 5 billion years, the sun's core will run low on hydrogen fuel, and gravity will begin to take over. As the core contracts, the outer layers of the sun will expand dramatically, transforming it into a red giant. This bloated star will engulf the orbits of Mercury and Venus, and Earth will become an inferno, scorched by the sun's intense heat. Eventually, the sun will shed its outer layers, leaving behind a dense, hot core known as a white dwarf. This stellar ember will slowly cool over trillions of years, eventually fading away into the darkness of space. But even in death, the sun will leave behind a legacy. The dispersed material from its outer layers will seed interstellar space with the building blocks of future generations of stars and planets. So while our sun's story may seem finite, it's just one chapter in the grand, ongoing saga of the cosmos, a story of birth, life, death, and renewal that plays out on a cosmic timescale. As we conclude our journey to the sun, we're left with a sense of awe and wonder. This celestial giant, the ruler of our solar system, is a force of unimaginable power and complexity. We've explored its immense size, delved into its fiery core, and traced the life cycle of a star from birth to death. And yet, for all we've learned, the sun still holds countless mysteries, waiting to be unlocked by future generations of explorers and dreamers. So the next time you feel the sun's warmth on your skin or gaze up at its light in the sky, remember the incredible journey we've taken together. It's a journey that reminds us of our place in the cosmos, interconnected with the universe in ways we are only beginning to understand.